Hey everyone, welcome to Inside Java, a podcast that discusses Java and OpenJDK and just that, a podcast that is brought to you directly by the team at Oracle that makes Java. My name is David Delabassée and I'm your host for this episode 12. We continue to look at some of the new JDK 16 features. Today, I'm discussing JEP 392, the packaging tool, with Kevin Rushforth. Kevin, welcome to the show. Can you start by introducing yourself?
Hi, I'm Kevin Rushforth. I've been working on Java client technologies, first at Sun and now at Oracle for about 20 years now. I'm a co-project lead of the OpenJFX project at the OpenJDK, which is where we develop the JavaFX API. And I've been involved in the Java Packager tool for a while now.
Thanks. So today we'll discuss JEP 392, aka the packaging tool. My first question is on the terminology. I've seen multiple names. The packaging tool is one, jpackage is another one. So which term should we use?
Oh, I think we can just call it jpackage. It is a packaging tool, but jpackage is the name of the command line tool. So just like JLink is the Java linking tool, jpackage is the Java packaging tool.
So jpackage it will be. First, what issue does jpackage tackle? Can you explain?
Well, the short version is the main purpose of jpackage is to allow an application developer to easily create a self-contained Java application. This will allow them to take that Java application, distribute it to whoever it is they want to run it, and have them be able to run it. The inputs to jpackage are a pre-built Java application, usually a set of one or more jar files, and a Java runtime. And jpackage takes those inputs and creates, as its output, a native application package that can be distributed. We support it on Linux, Mac, and Windows. And the main thing that it gives you as a benefit is it allows you to support native packaging formats to give the end user of your application a natural installation experience on their platform. It provides some customization, and so we expect that it will actually tackle most use cases.
Okay, so in a nutshell, jpackage tackles the distribution of Java applications. We're discussing this today because jpackage will be made production ready in JDK 16. But if we look at its history, jpackage started to incubate in JDK 14 through JEP 343, but before that, there have been multiple similar related initiatives. We had JEP 311, the Java Packager API and CLI, which at some point was withdrawn. But before that, we had in JDK 7, I believe, the JavaFX packaging tool. Then the Java Packager, I believe, in JDK 8. So that history, the history of packaging Java application seems a little bit convoluted for people like me who are not tracking this very closely. So is there any links between jpackage and all those previous efforts? Can we discuss this?
Sure, I'd be happy to. The packaging tool, as it is now, evolved over time. It started out as a JavaFX specific tool way back in JDK 7, and it was called JavaFX Packager at that time. In JDK 8, we renamed it to Java Packager because it wasn't really limited to JavaFX apps. It could be used to package up other desktop apps using Swing and AWT or non-GUI applications. And so Java Packager existed in JDK 8 through JDK 10. And at that time, we were planning to evolve Java Packager, but keep it roughly the same. And that's where JEP 311 came in. It was to formalize the command line interface and runtime API of Java Packager. It was still intended initially to be built and delivered as part of JavaFX. And at the time, that made sense because it was bundled with the JDK. In JDK 11, JavaFX was decoupled from the JDK, so a new approach was needed. And that's why we withdrew JEP 311. And at the same time, when we created JEP 343, we realized that this was an opportunity to create a tool that was less worried about focusing on what Java Packager used to do when it was part of JavaFX, and something that would fit much better with JLink and other tools in the JDK. And so that's why we created a new JEP to take care of that. So JEP 343 was the one where we developed the packaging tool. It was inspired by Java Packager, but it didn't have to carry all the legacy baggage. And the emphasis was on a clean design and feature set and a command line interface that fit in naturally with all the other tools. During the development, which was getting close to sort of the middle of the JDK 14 timeframe, we realized that it was not quite ready for production. We were, or rather, not quite ready for finalizing the API and the command line interface. And so we made the decision to make it an incubating tool to give us a couple of releases to stabilize it. And the goal was to do that in JDK 16, which we've done with JEP 392.
Okay, let's now discuss the tool. So the tool itself is called jpackage, right?
Yes.
Okay, another terminology question. How do you call the outcome of jpackage? Again, I've seen multiple names, multiple terms being used. A platform-specific installer, a bundle, and so on. So which one is correct?
Right. This one's a little bit trickier because I myself will use multiple names. jpackage creates a package. So I guess we can call it a package, but I often will use the term installer interchangeably with that, especially on Windows, where you tend more to think about a .exe file that you deliver as you double click on it and it pops up an installer. But Linux tends to use the term package exclusively. So when you distribute an RPM file, that's a package. And so usually I'll use the word package, but sometimes I'll use installer.
Mm-hmm. Now, you mentioned RPM package. So jpackage is supported on Linux, but it's also supported on Windows and Mac OS. So which package types exactly does jpackage support on all those different platforms?
On Windows, jpackage produces either an exe or an MSI package. On Mac OS, jpackage will produce either a DMG or PKG package. And on Linux, depending on what package manager you use, will generate either an RPM or a deb package.
Okay. In the JEP, I also saw that there is a package app image type. So what is this type for?
Oh, yeah, there is. An app image is a directory tree with the self-contained application. It includes the Java runtime and the application launcher. When you create one of those other packages like an exe or an MSI or so on, jpackage will actually create the app image first. So what it is it will take the runtime, possibly J-linking it, and it'll take your application, copy it into a directory tree, and then that is your self-contained application. And from there, it will then produce the installable package, the exe or the PKG or RPM file. But it also has the ability to make that app image its final output if you prefer that instead. And there's a couple of reasons you might want to do that. One is you might want to then go customize it by adding a few more things yourself that you couldn't do at jpackage time or that jpackage didn't allow you to do. But another reason is you might just want to zip that up and send it off to somebody without worrying about creating a native installer.
Okay. Now, in a nutshell, I'm a developer and I want to create an installer for my Java application. So how does that work? What should I do?
So in the simplest mode, all you have to do is point jpackage at your application jar file. It'll bundle it with, by default, the JDK that you're running jpackage from, and then it will use JLink to create the package that you could install on your system. And then the nice thing about that is because it includes the Java runtime, you can distribute this to other users who can install it on their system without needing to first install Java. The only required options that you have, jpackage has a ton of different options, but the only ones that are required are the name of your application, where to find the input jar files, and which one of those is the main jar file. And it will do all the rest for you. There's a lot of other options to control it. By default, as I mentioned, it uses the Java runtime that you run jpackage from. It can use other runtimes as well, and we can talk about that later. The developer can specify a number of options to jpackage, and these are truly optional things that you don't have to. You can specify launch time parameters. So if you need to run your Java application with a 2 GB heap, you can specify launch my application with a 2 gigabyte heap, and the end user doesn't have to know or care to do that. You can pass in file association such that it will associate your application with a .xyz file such that when you double click on that, it will launch your app. You can specify that it will show up in the start menu on Windows or that it will create a desktop shortcut, and as well as update rules for installable packages on Linux.
Okay. Under the hood, gpackage relies on platform-specific tools. Can you tell us which one?
Yeah, on Windows, it uses Wix toolset, and that's the Microsoft recommended tool to produce MSI and EXE installers. On Mac, it just uses the Xcode command line tools. And on Linux, it depends on which package manager you use. Linux systems that use Red Hat Package Manager, we use RPM util. And on Linux systems that use the Debian package manager, such as Ubuntu, we use jpackage and fakeroot.
Okay, but that also means that gpackage is not cross-platform. So you can't generate from a given platform a bundle for a different platform. For example, generate a Windows installer from Linux, right?
Yeah, that's right. And there's 2 reasons for that. First, the package produced by jpackage is in the native format of that platform. You're creating an EXE on Windows or a DMG on Mac. The second reason that it's not cross-platform is that it includes the JDK for that platform. So you can write Java code that's platform independent, but it ultimately runs on a JDK that is a JDK for Windows or for Mac or for Linux. Well, that JDK is included in the package. The advantage of that is that this package can then be installed and run on any end user machine of that operating system, regardless of whether they have ever had Java installed on that machine. So you don't have to have any additional software dependencies.
Which is nice. Now, staying on the platform-specific question, I saw that the Mac bundle can be signed. So does that mean that I can submit my bundle produced by gpackage to the Apple Store? Or are there any kind of limitations regarding that? Notarization comes to mind, for example.
Well, all of the pieces are there. We do handle code sign. We also handle notarization so that starting with macOS 10.15 and later, Apple's requiring it not just to be signed, but to be notarized. We support that. But there are still a few more finishing touches to make it look seamless. So it should be possible today to do that, but it isn't as easy to do for the developer. So there's still some steps that we leave to the developer.
Okay. Now, let's go back to Java. You said that gpackage bundles by default the Java runtime that is located on the developer's machine, right?
Yes.
Is it mandatory to bundle a Java runtime along with the application that you want to ship?
Yeah, jpackage needs a Java runtime in order to run your Java application. And the way it does that and make sure that it can be distributed and run is by bundling that runtime. So it doesn't have to be the same runtime that you run jpackage from, but there has to be some Java runtime to run it.
Yeah, that makes sense. But what if I want to bundle a different Java runtime than the one I'm currently using?
So as I mentioned, by default, it will pick up the runtime from jpackage, but there's an option that says use this Java runtime. If you let it use the runtime that it's running from itself, it will run JLink to select the list of runtime modules. If you point it to a runtime, you can point it to one where you've already done the JLink step. So you can customize that runtime however you want. Or the other reason people might want to do this is you might be running the JDK 16 packaging tool now that it's final, but you might want to bundle a Java 11 runtime. Well, we support that as well.
Okay, and what about the application dependencies?
Right. For non-modular applications, in both cases we have a default, but if you have a non-modular application, we just pick whatever the system default is, which is going to give you almost all the modules in the Java runtime. You can use command line options to trim that down, but you as the app developer need to figure out your dependencies. We don't directly run JDEPs for you, but that's a tool that you can use if you want to help guide the selection of modules. For modular applications, your application already has a module info.java that determines the set of modules that you need. And when we run JLink, it will use that.
So it's fair to say that gpackage leverage JLink, right?
Yes. We sometimes get asked the question, what's the relationship between jpackage and JLink? And the way I like to think of it is that jpackage picks up where JLink left off. So JLink is great for taking a Java runtime, a set of JMod files, which describe your module, possibly with native code, and links them all together, creating a custom Java runtime. What jpackage does is it takes that runtime, and in fact, it will run JLink for you in many cases, but whether you run JLink yourself or jpackage does it, you're ending up with a Java runtime over here and an application over there, and we'll put it all together, and then we will create a native package from it.
Cool. Something else. When I read the JEP, I first thought that the installers produced by gpackage were not interactive. I then realized that there were some options to let the end user customize the installation process. Did I get that right?
Yeah, there is. We don't actually have a GUI inside jpackage itself, but if you create, for example, a Windows exe installer, you can create that in such a way, and we provide a command line option for it, that it will ask you where you want to install it. You can say, here's my default location, which is usually program files, name of your application. And then if you've selected this option, we will put into the exe installer the ability for it to pop up a dialog that allows you to change that. So that's just one example of an interactive installation step.
Sweet. So this is probably a naive question, but until now we have discussed about application installation using bundle produced by gpackage. But what about uninstallation? I mean, is there a way to properly uninstall those applications?
Yes, because we use the standard platform supported installation mechanism, we also pick up the platform supported uninstallation mechanism. So for example, on Linux, we will generate a PKG file. A package, an RPM file, I meant. And that RPM file can be installed and uninstalled just like any other RPM file on Linux. So anybody who knows how to install packages on Linux and knows how to uninstall will be able to take a jpackage produced installer and do the same thing. And the same thing's true on Windows. You double click on your exe installer, it will let you install it. Well, it shows up in your control panel settings list of programs that are installed, and you can click on it and uninstall it.
That makes sense. So I think the next obvious question is, what about updating those applications? Is there any way to properly update them?
Well, there's no auto update support. As with uninstallation, most of these packages will support versioning. So on Windows, for example, your exe file can specify a version. And so if you double click on something, an exe file of a newer version of the same app, it's smart enough to go uninstall the old version and install the new version on top. RPM has similar features for this. And for Mac, you would just drag it into the app folder and it just overwrites it.
Okay. Let's see. Can we now discuss some limitations? So I saw in the JEP that there is no splash screen support nor any JavaFX specific features. Can you comment on that?
Right. The reason we put that in the JEP is the old Java packager from which we derived this did have support using JavaFX for a couple of specific features like splash screen. What we've done is separate and decouple that out so that jpackage just does the job of packaging up your app. You can still create your app with a splash screen or create your app using JavaFX. So we've taken several of the JavaFX demos and used jpackage to create them, and they run just as you would expect. Also, we've done a Swing app with a splash screen, and it works just fine.
All right. The time is running. So is there anything you would like to add on jpackage?
I think we can mention one more thing, and people might not be familiar with this if they were running the old Java packager tool, and that's that now that we're part of the JDK, we also provided support for the standard tool provider API. So just like you can run JLink and Delabassée either from the command line in say, a make file or some other script, you can also use a Java program and access Delabassée or JLink using the tool provider API. jpackage similarly can be run either using the command line or using the tool provider API.
I guess that you would typically use the tool provider API to integrate gpackage in your build infrastructure, right?
Yeah. And it depends. Some build infrastructures want to control it with a Java program. Others, you'll run a script of some sort, and then you'd use the command line option. So we give you both options.
Now, there's something I'd like to quickly discuss before we talk about the future. So a question I've heard in the field, and I'm sure you heard that question too. So some people are asking between the potential relation between gpackage and Docker, or the potential links between Graal VM native image and gpackage. So can you address that?
Sure. The way I usually like to say is that jpackage is really about creating an installable package for Java applications. You can certainly take that application and include it in a Docker image. So we're now talking about typically a Linux solution there. But there's no direct connection between the two. We actually looked at what it might take or what there might be some synergy between them and concluded there really wasn't anything special we could do there. We're just creating a package like any other Linux package, and yeah, it can be put into a Docker image. As far as the Graal VM native image, or rather native image support, we expect we'll be able to leverage Project Laden once it's available. Right now, though, we're about running regular Java applications with a Java runtime.
So we mentioned that gpackage has started to incubate in JDK 14 and that it will be a production-ready feature in JDK 16. So now that we almost have the first production-ready version of gpackage, can you share some thought about the future, about how gpackage might evolve?
Right. So now that we're standard in JDK 16, we have a number of things that we're working on. First, we kind of touched on this earlier. We would like to add full support for macOS App Store, meaning having options so the user can easily control which certificates they use, how they sign it, and notarize it, such that once they're done with that, they'll be able to submit it to the App Store. Another thing that we would like to do is right now, we always bundle the Java runtime with the application into the package. And the reason we do this is so that you could distribute that app and run it on any machine that may have never had Java installed. And that's still going to be the most common way to do this. We have been asked, and so we're looking at doing this. What about enterprises that might have a variety of applications from different vendors that they want to run, where they want to control the Java runtime a little more carefully so that they can update the Java runtime independently from the application? And so for supporting that, we're looking at the ability to create a package that instead of including the Java runtime, includes enough information about what modules you need in the Java runtime and what version you need. And then it will go find it on the end user machine. So that's still a work in progress. It's just an enhancement we're looking at for the future. Another thing that the old Java packager did that we'd like to put into jpackage is the ability to create packages for non-interactive services so that you could install a service on your Windows or Mac. And then we're looking at some additional customization for the Windows installers to be able to do more branding and to add additional control over what questions are asked, what dialogues are popped up by the installer.
All right. Thanks, Kevin. We'll have to wrap up shortly. So any final comment?
Well, sure. Now that JDK 16 is about to be released with jpackage as a final, no longer incubating tool, if you haven't yet used jpackage, or if you haven't used it recently, please download a release candidate of JDK 16 and give it a try.
Perfect. Kevin, thanks again for your time. It was a pleasure to discuss gpackage with you today. And given that this is the Inside Java podcast, I'd like to close by asking you to give us a quick peek inside your day.
Sure. I'm an early riser, so I usually start my day before the sun is up by catching up with messages from colleagues on Slack or email, answering any questions that arise. We have team members all the way around the globe, and so they've sent me email overnight or Slack messages. As most of us are doing these days, I work from home, so my commute is great, but I kind of miss the casual interactions with my local coworkers. Most of my day I spend on Java FX between code reviews, mentoring other team members, and some coding. When I'm not working, I like to read, play board games, watch movies, and play golf, although I'm not very good at that last one.
Sweet. Thanks, Kevin.
Thank you for having me. It was my pleasure.
Bye.